So this problem comes from 5.2. It's question number 15. It says consider this geometric series where n is equal to 1 to infinity of 5 times 0.9 to the n minus 1 power. And it says if we write it in the standard form, so the standard form, infinities keep getting turned into ovals, hold on. All right, so the standard form looks like this. Where it's a times r to the nth power. We don't have r to the nth power here. We have a value to the n minus 1 power. So we have to change this around. We're going to rewrite it using some exponent rules so that this would be r to just an n power. So if I was to rewrite this, so we're just going to look at this part. Now, exponent rules. We have an exponent rule that says if you have n to the m and n to the, or here, let me use some other variables, x to the m power over x to the n. We have the quotient rule that says we could rewrite this, use same base, and you subtract the denominator exponent. So I'm going to do the reverse here. So what would this part, so just look, focusing on this part, if it looked, it's combined into this, but let's rewrite it as, let's undo that simplification. So that would have been 0.9 to the n, and it would be 0.9 to the first. So that is what I highlighted in blue here. This is what it would have started with, or how I can rewrite it using exponent rules. And then I still have this 5 out in front. So now that I rewrote that, I now have a value to the nth power, and this is 5 here times this, and the bottom here, that's just 0.9. 0.9 to the first power is 0.9. So I'm going to put it with the 5 so that all my numbers are together, because that doesn't have to be kept over here. And now I have it in this form. And so now I wrote it in this standard form for a geometric sequence. And so my A would be right here, and my R would be the base of that exponent of n. And so my R, the absolute value of R, has to be less than 1 using the geometric series test to see if it converges. If it converges, this is true. If it's not, if the absolute value of R is not less than 1, then it diverges. So here, the R is equal to 0.9, and that is less than 1, so then it's going to converge. And to find where the exact value that it converges to, and I would take the first term and divide it by 1 minus R. So the first term here, if you had plugged in a 1 here or here, you would get you will get 5 for the first term. The 0.9s would cancel, or over here, 0.9 to the 0 power is 1. 5 times 1 is 5. And then you'll have 1 minus 0.9. And so this is what it converges to. And yes, you could simplify these, but it says that decimals are allowed in the answers for these problems, so you can leave it like this. Otherwise, you could say A is equal to 5 divided by 0.9 is a decimal. We wouldn't want to write it as a decimal. We would say 50 over 9. And then we would, it would converge to 5 divided by 0.1, which would be 50. But the MyOpenMath accepts these answers.